Hello everybody, Mr. Hennon here for a little Henstitute help video. This is a fun one because we have this kid on a slide. They're going to go down and we're trying to figure out the acceleration of the child and the speed at the bottom. So a little bit of kinematics, a little bit of dynamics. First thing I'm going to do is just draw a free body diagram for this kid. So the first force obviously we have acting on him is we have their weight pulling them straight down like this. So this would be the force of gravity. We know the mass of the kid, so we could actually calculate this if we wanted to. It would be the mass of the kid times the acceleration of gravity times, well, that would be it. Just those two. So 23 kilograms times 9.8, and we would have his weight or his force of gravity. The other one that we have acting on him would be a normal force. Remember, normal forces are perpendicular to our surface, so this would be acting in this direction like this. It's a normal force. Now, on a normal slide, there would also be friction acting on him, but later on it says, assuming there is no friction on the slide. So this slide must be covered with ice or it's just really, really slick. So we have no friction, or it's so minimal we can kind of ignore it. If I'm going to try to figure out the acceleration of the child down the slide, then I really need to take this force of gravity and split it up into two components. One of the components is going to be perpendicular to the slide, so we're going to have a component of this. This is what we call the perpendicular component of gravity. Now the nice thing is the perpendicular component is just going to be equal to the normal force here, because the child is not going to move perpendicular to the slide. We want him to go down the slide instead. So the other component I have to split this up into is a parallel component. So we have a component pulling this way. I call it F parallel. And if there was friction acting on this thing, I'm just going to show this and then I'll get rid of it. If there was friction, friction would be acting in this direction. It would actually be acting up the slide in that direction. That would be our force of friction. But since we don't actually have that in here, we're going to go ahead and get rid of that. Goodbye. And we'll just go back to this idea of parallel force. Now the parallel force is what's going to cause them to accelerate down the slide. And we can find the parallel force by taking, get my pin here again, we can find the force of gravity, oops, gotta get my pin, my force of gravity, which is just mass times gravity, but then you multiply it by the sine of the angle. So Fg times the sine of theta, or mg times the sine of theta. Since that's the only thing acting down the incline, that would also equal, this would be this is going to be the net force down the incline, or parallel. So this should equal the mass of the kid times the acceleration down the incline. I'll call this A parallel. So I'm going to set this equal to m times A parallel. Now the reason I'm doing that is I want to kind of show you that this is the mass of the kid and this is the mass of the kid. Goodbye, mass of the kid. You can actually cancel from the equation. So to find part A, to find the acceleration down the incline, we can actually just take the acceleration of gravity times the sine of theta. In other words, without any friction, it's a component of gravity that's down the incline that causes them to accelerate. Then for the second part, to figure out how fast they're going at the bottom, this is going to use an old kinematic equation. We know how long it is down the incline, so I treated that as like an x along the incline. You could actually, in other words, I'm kind of treating along the incline as an x direction, if we will. The acceleration would be this value right here, so whatever I get in part A, and then we are initially not moving, so this was 0. We're trying to find VF. My idea is I would use the fact that VF squared equals VI squared plus 2AX. Since I have everything, I just have to solve for VF and I can find how fast they're going. Hope this helps. Sorry for the little hiccup in the middle.